Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in short range wireless communication. We're going to see the introduction about wireless communication. What is wireless communication? What are the benefits and drawbacks? What are the challenges in wireless communication? And what is the main reason for widespread of wireless devices right now? All these things we're going to see in this particular video, right? To start with, we will start with what is wireless communication, right? I've already explained in previous videos about the basics about short range wireless communication, what is wireless communication, everything. But once again, I'll tell you, wireless communication is uh, any transfer of messages between a transmitter and a receiver with air as a transmission medium, right? That is called as wireless communication. We know that, right? So you can see a transmitter and a receiver. The channel will be the air will act as a communication channel, right? A very good example is a lecturer standing on the dais and delivering this lecture. Uh, in that perspective, the lecturer will be transmitting the voice signal and students will be receiving the voice signal. So the lecturer will be acting as a transmitter and the students will be acting as a receiver, where air will act as an transmission medium. That is a very good example of a wireless communication. And when it comes to technically, not only a voice signal, you can able to transmit voice data using electromagnetic waves in free space, right? So this transmission of electromagnetic waves between a transmitter and receiver with air as a medium, that is known as wireless communication, right? And for this wireless communication, uh, frequency band plays a very important role, right? Any particular channel, if you take any particular channel, frequency band is very, very important, right? The specific frequency range and frequency band, where we call it as a band of frequency as bandwidth. That is, the higher frequency minus lower frequency will give you the bandwidth. Bandwidth is nothing but the capacity of a particular communication channel. Say, for example, if you take UWB short range wireless communication technology, the minimum bandwidth will be 500 megahertz. So, for every communication, channel plays a very vital role, and the capacity of the channel is very, very important. So we can say bandwidth is a range of frequency, the capacity of the channel, right? When we say the capacity, more the capacity of the channel, we can able to transmit more amount of data. Data can be transmitted, more amount of data can be transmitted. And whenever the capacity is large, it's not only we can transmit more data, we can also transmit data at a higher data rate, which is called as bit rate. It's called as bit rate. Bit rate is nothing but number of bits that can be transmitted per second, right? You would have come across 10 kbps, 20 kbps, 20 mbps, like that, right? So it's nothing but bits per second, right? So how many bits it can transmit, we can able to transmit using that particular technology. That speaks about the speed of transmission. So everything is based upon this particular capacity, right? And we can have different channels used to transmit information in parallelly. That is, simultaneously we can able to transmit in wireless communication. And when it comes to wireless communication, the important benefits, the important application is the mobility, right? It can able to communicate anywhere, and it is easy to configure and low installation cost. But when it comes to difficulties, we will not have the high-end sophistication like a wired system. Whereas right now we have improved wireless technology where the noises is reduced. Uh, we have good connectivity, but just before a decade, we don't have powerful wireless technologies where we have a lot of difficulties. Where since we are using free space as the communication medium, definitely we'll have noise. That is, the channel will be unpredictable, and it will the bandwidth will be very less, and the equipment cost will be very high, and we will have a limited bandwidth because of a regulated spectrum. Right now, we have most of the spectrum is regulated, so you'll have a limited bandwidth or limited range for each and every applications. That is one important drawback. And sometimes, in not wireless system, in some wireless systems we will need a backbone systems which need a wired connection, right? So these are the advantages and disadvantages of wireless communications. And coming to challenges, we have a lot of challenges with wireless communication. The first and foremost thing is efficient hardware. What is efficient hardware? Whenever you take wireless communication, power plays a very vital role. Right now, you have a lot of gadgets with you, right? Number of devices that is connected to the internet is increasing day by day, and you have a lot of devices like mobiles, your Bluetooth headsets, right? A lot of devices where we can able to communicate wirelessly, right? And if you take any particular devices that can able to communicate wirelessly, power plays a very vital role. That is, it has to consume very low power, right? Even if you take mobile, we will have to frequently charge it, correct? So charging your battery is very very important for mobile for your mobile devices. So obviously we will search for a good mobile device which can able to hold power for a more longer period of time, right? So power plays a very vital role. So efficient hardware is very important, where we need to find out the transmitter and receiver, the other processing tools which consumes very less power. That is one important challenge. And the spectrum, right? There should be an efficient use of radio spectrum. You know that the mobile device is increasing day by day, so the number of users to a mobile network is increasing. Like 10, 15 years back, people will not be able to, not all, everyone had mobiles. But right now, everyone is using mobile with more than one SIM or a dual SIM like that, right? So which means number of devices, number of users is keep on increasing. So the spectrum which is allocated has to be used very effectively. So a lot of other techniques has to be followed, like cellular frequency reuse, medium access control protocols, all those things. This is another important challenge. And very importantly, integrated service, right? It's not only voice and data. Right now we are transmitting a lot of multimedia uh, messages. We have video conferencing, audio conferencing, all those things, right? We need an integrated service, and similarly, network support for user mobility, right? The handoffs has to be very perfect. What is handoff? Whenever you travel, right now, when you are traveling in a car and in a bus, you can able to talk in your mobile without any issues. That you don't have any disconnection right now, because the technology has improved a lot. But if you take a decade before, say for example, if it is in 2004 or 2005 or nearly 2000, right, whenever the mobile phones emerged, where we will not be able to talk continuously while traveling, because we will have a lot of disturbances. Like whenever the call is getting routed from one tower to the another tower, your call get disconnected or dropped, where you have to recall to that particular person and you have to speak, right? But right now, all these techniques has improved a lot. So this plays a very vital role. A proper handoff is also very important, and location identification is very important. Handoff is nothing but without disconnecting, the call has to be routed from one particular tower to the another particular tower, right? And maintaining quality of service over unreliable links. We always call wireless wireless communication or a wireless link as an unreliable, because we will not be sure whether our data will be transmitted in the appropriate manner, in the right order, uh, without any errors, without any distortions like that. But in wired communication, you will have a specific channel, dedicated channel, where you will have to transfer the data through that particular channel. So any particular error can be easily detected. But that is not the case in wireless communication. That is another important challenge. And connectivity and coverage, right? So connectivity and coverage, even now we have some coverage issues whenever we move to different places. So that is an important challenge, and it has to be cost efficiency, right? And another important challenge is fading, right? Whenever it comes to wireless communication, fading is nothing but the loss of signal strength, right? And in wireless communication, this plays a very vital role. As distance increases between transmitter and receiver, definitely fading comes into effect, right? So fading is an important challenge in wireless communication. And apart from it, you have another important challenge, which is multi-path propagation, which is very, very important scenario. right? This is very important scenario in wireless communication. What is multipath propagation? That is, I would like to give you this particular example where mobile communication, we always use electromagnetic waves, EM waves. And EM waves, we know that EM waves can propagate in different, that is different modes of propagation. That is reflection, diffraction, scattering. So reflection is what is reflection? Any particular surface, it will just reflect that particular word, that particular wave, and diffraction is another particular technique, and scattering is another particular technique, which is used for propagation by EM waves. We will see what is that, right? Uh, Reflection occurs, you already know what is reflection, but when reflection will happen, right? When a wave incident on a particular object, right? These three things can happen: reflection, diffraction, scattering. But there are certain conditions. Say, for example, if your wave, if the EM wave, it has a particular wavelength, right? And if the wave incident on a particular object which has a very large dimension, which has very large dimension compared to the wavelength, right? If the dimension of the object is greater than the wavelength of this particular wave, then reflection will take place. I repeat it again, right? If the dimension of the object is bigger than the wavelength of that particular wave, then reflection will take place. Whereas if the dimension is small when compared to the wavelength, then scattering will take place. And there is something called diffraction. Diffraction is nothing but bending of waves, right? Whenever there is a sharp edges, bending of waves can happen, right? So the electromagnetic waves can able to propagate through this particular techniques: reflection, diffraction, and scattering. So now if you take this particular mobile device, right, this has to receive the signal from this particular tower, where you can see because of this particular building, a diffraction will take place, right? And because of this tree, a reflection will take place or scattering will take place. And you can see reflection here. Like this, instead of one particular wave, you will receive the same uh, from the same source through multiple propagation, through multiple waves. That is called as multiple propagation. And this is a very important challenge in wireless communication, right? And high probability of data corruption, that is errors, and also security plays a very vital role. Security is an important challenge in wireless communication, right? Any data that has to be transmitted between transmitter and receiver, it has to be very secure, all right? So we need a proper privacy and authentication for wireless communication. But there are chances that when compared to wireless communication are more vulnerable for the attacks, right? The authentication issues, hijacking, everything, right? Eavesdropping, right? So these are the important challenges of wireless communication. And uh, when it comes to short range wireless communication, so far we have just seen what is wireless communication. And when it comes to short range wireless communication, it is the same, that is same wireless communication that is going to happen for a very short range, that is for few centimeters to hundreds of meters. And we have a lot of technologies in this short range wireless communications, which is Bluetooth, Wi-Fi, Zigbee, and UWB. We are going to post videos for all those particular technologies. So all these are indoor communication, wireless, short-range wireless communication technologies, where UWB is a very powerful short-range wireless communication technology, right? And if you take the last 3 decades, as I said before, the number of devices that is connected to the internet is increasing day by day. It's not about only your mobile phones. You can able to, right now people are connecting laptops, your mobiles, right, your headsets, right, your smart watches, right, smart tracking devices. Lots and lots of devices are there, where all these devices are communicating in the short range and they are connecting to the internet, which means short range wireless communication is booming day by day, right? And as for Wireless World Research Forum, it is estimated that by the year 2017, we are in 2025 right now. By the year 2017 itself, it is expected that 7 billion people in the world will be using 7 trillion of wireless devices in 2017 itself. And by this time, you can just imagine the number of devices that can be connecting wirelessly, right? So the majority of devices are short-range wireless devices which can interconnect people, interconnect devices, interconnect environments. So short-range wireless communication is a very important communication where almost all the gadgets which is emerging right now, it works in this particular short-range wireless communication, right? And the main reason for this widespread of wireless communication, what is the main reason for the spread of wireless applications or wireless devices? The main thing is we can able to access higher frequency in the spectrum very easily now, and we have emerged solid state devices which can able to amplify millimeter wavelengths, right? And another important thing is we have efficient compact antennas for short range devices, which was not existing before in like 15, 20 years back. Right now we have very small compact antennas. Even in your mobile phones, in all mobile phones you'll have antenna, but you're not able to see it because we have an integrated compact antenna which has been inbuilt with the mobile. And similarly, the development of SAW, which is surface acoustic wave frequency components, which allows generation of UHF with very simple circuit. UHF is nothing but ultra high frequency. We can able to access the ultra high frequency using simple circuits because of SAW frequency components. And we are using right now digital modulation techniques where we have number of modulation techniques to improve the quality, the reducing the noise, processing, everything can be done. And very importantly, miniaturization of devices. If you take the devices which is emerging right now are very small. That's because we have hybrid integrated circuits, analog and digital functions, RFIDs, and we have compact size cellular handsets. These are the main reasons for spread of this wireless applications, right? And we will see the characteristics of short range radio, which is the RF output, which starts from several microwatts to 100 milliwatts. And the communication range, as I said before, it ranges from several centimeter to 100 meter. And most of the short range communication happens in indoor communication. And we have omnidirectional antennas right now, where the antennas can able to radiate uniformly in all direction. That is omnidirectional antenna, which was not the case before. But right now we have sophisticated antennas which can able to radiate omnidirectionally. And simple construction and low price is also another reason. And unlicensed operation that is permitted, and UHF operation, right? Ultra high frequency operation, and battery operated transmitter and receiver, which makes the devices portable, right? These are the characteristics of short range radio communication, right? And when it comes to short range radio communication, I've already said we have a lot of different technologies, right? And all these technologies will have a specific characteristics, and we have specific frequency ranges. And most of the short range communication, say for example, Bluetooth, WLAN, Wi-Fi, most of this works in this ISM band, which is 2.4 gigahertz. If you see most of the short range communication, it works in 2.4 gig. You can see here, right? Most of this communication takes place in 2.4 gigahertz, the short range communication. And each and every application has its own characteristics. If you take RFID, it is a very short range, and it has active and passive transponders. And if you take WLAN, it uses OFDM modulation. It has high data rate. And similarly, if you take WPAN, we have medium data rate and low cost, right? And if you take wireless microphones, where we have voice modulation, like that, each and every application has its own frequency range and own characteristics. And depending upon the applications, the frequency range will vary and the characteristics will vary, right? And this is the applications of short range wireless communication. And when we mentioned already UHF, that is ultra high frequency VHF, very high frequency. It's nothing but the electromagnetic spectrum. The complete electromagnetic spectrum is already divided into different frequency slots, different frequency ranges like VHF, UHF, SHF, and EHF. That is a very high frequency, ultra high frequency, super high frequency, and extremely high frequency. And you can see those frequency ranges. Like, as I said, the ASM band starts from 2.4 gigahertz, right? All this are HSF band, and this comes under uh, UHF, right? You can see from 100 megahertz to 10 gigahertz, we call it as microwaves. And like that, we have different frequency bands where you can see in this particular diagram where you can see the frequency ranges start from DC and then up to 3 kilohertz, just low frequency, and then 3 kilohertz, and then 30 kilohertz, and then 3 gigahertz to 300 gigahertz. The complete band of frequency, you can see this is split into microwave, this is split into radio frequency spectrum, and this is split into low frequency spectrum. So the complete frequency, the complete electromagnetic spectrum is divided into different frequency ranges, spectrum. And you have separate applications for each and every range of frequencies. You can see microwave, it works on satellite, and for RF communication, we use broadcasting, mobile communication, everything. And low frequency devices, you have all this subways, AC power, all these communications, right? And you got to understand the relationship between frequency and wavelength, where frequency is equal to C by lambda, where lambda is the wavelength and C is the light intensity, right? And we can also calculate a wavelength when we know the frequency and the light velocity. We already know that it's a constant. So if you know the frequency, we can able to find out the wavelength at the vice versa, right? So today what we have seen is we have seen introduction about wireless communication. We have seen what is the advantages, disadvantages, what are the challenges of wireless communication, and then we started what is short range wireless communication, what are the advantages in it, what is its characteristics, right? All this we have seen, and we have already seen electromagnetic spectrum, what are the different frequency ranges, all those things, right? I believe this video will be very useful for you. Thank you, my dear students.